All right, so I finished my general announcements. Students were already given time to complete the multiplication at the top of page 30. In terms of homework, students are reminded that 82, 3, and 4 are dead today. 85, 6, 7 are due tomorrow for the first time. Students just got back CFU 22, and normally that would mean that they have until next week, Tuesday, to retake it. But I'm going to cut that deadline 1 day short, and it needs to be done by this week on Friday. Okay, so students have until the end of this week to retake CFU 22. Okay, now this is the schedule that shows the remaining weeks that we have in the school year. And the quick review or summary of this is every week there's some type of assessment going on. This week on Friday is CFU 23. Next week, Thursday, is the test, which covers this entire note packet. The following week on Tuesday will be the quarterly assessment. Students need to arrive with a charged Chromebook. And then the last week of the year, there is an optional CFU, which historically students do really, really well on. It's kind of like the last opportunity you have to boost your grade if you're fighting for something. Okay? All right, today, again, we're going to get through 2 context problems after we do some fraction review. And this is the fraction review is at the bottom of page 30. So problem number 1 says, perform each fraction operation below. Be sure to completely reduce your final answer. Now, I want to be clear on something, that when it comes to multiplication, you are allowed to just multiply straight across. We talked about this last week. But when it comes to addition and subtraction, you are not allowed to simply add and subtract across. Here's what I'm pointing out. 3 times 25 is 75. 5 times 18 is 90. There is absolutely nothing wrong with that, although we will need to talk about how to simplify that in a moment. However, for the other 2 problems, if you notice I'm now writing in red, if you just add across or subtract across, what you're doing is completely wrong. You can't just do 5 plus 4 is 9 and 6 plus 5 is 11 and call it 9/11ths. You can't just say 2 minus 3 is -1, 3 minus 4 is -1, and -1 divided by -1 is 1. Totally wrong. Okay, so you are allowed to directly multiply across. You are not allowed to add and subtract across. Now, before we get to the addition and subtraction, let's get back to the one problem that I've done correctly here. Can anyone name a number that can divide both 75 and 90? 5 is one of those numbers. Now, by the way, just based on the amount of silence I got, remember, let me reset my calculator. If you ever have trouble figuring out a number that divides both, remember, you can go to y equals, and you can type 75 divided by x and 90 divided by x. Okay? And now when you go to the table, what you're going to see is, what does this fraction become if I divide both these numbers by a certain number? For example, if you divide them both by 1, you're not changing anything. You're just going to get 75 over 90. Now, Jordan a moment ago said 5. And what the table is telling us is if you divide both numbers by 5, you get 15 and 18. Now, what other number is on the screen that shows we could have divided them both by that number? You got it. Thank you, Mr. Phillip. You'll notice the table also says if you divide both numbers by 3, it turns it into 25 over 30. So that actually tells me we can divide it by 5 and we can divide it by 3. I'll do it in that order since Jordan mentioned 5 first. So if we divide both by 5, the calculator told us this turns it into 15 divided by 18. But the calculator also told us, which is what Philip pointed out, that we can divide both numbers by 3. And if you divide both of these numbers by 3, you get 5 over 6. By the way, if we can divide them both by 3 and we can divide them both by 5, well, 3 times 5 is 15. That implies we could have scanned down and seen that we could divide them both by 15. That is the greatest common factor. And if we had divided by 15 and from the start, we'd be done in one step. Okay, 5 over 6, by the way, is the final version. There is no number that divides both 5 and 6. So that is the reduced fraction. Now, when you are adding and subtracting, what I talked about last week is you can only add directly across or subtract directly across if the denominators match. The denominators have to be the same number. And the quick and easy strategy to make this happen, again, I said some people like to call this cross multiplication, even though that's not really what you're doing, is you use this denominator to multiply this fraction by 5 over 5, and you use this denominator to multiply this fraction by 6 over 6. And if you do that, if you multiply the first fraction by 5 over 5, the denominator turns to 30. If you multiply the second fraction by 6 over 6, that other denominator also turns to 30. So here's how I'd show my work. I'm going to multiply the first fraction by the other denominator, 5 over 5. That turns that fraction into 25 over 30. But I'm also going to multiply the second fraction by the first denominator. And that turns that fraction into 24 over 30. So we have 25 over 30 plus 24 over 30. And because the denominators match, you are now allowed to add directly across. So 25 plus 24 is 49. Remember, the denominator does not change at all. Now, the directions are reduce the fractions. Can anyone think of a number that divides both 49 and 30? Yep. Yeah, go for it. I'm going to go for a second time. Can anyone think of a number that divides both 49 and 30? So far, I've gotten silence. Now, what I would say is that there are 3 different ways you could kind of do this. One of them is in your head. I really like 49. Can anyone name a number that divides 49? 7, and that's actually the only one. I mean, other than 1 and 49. 49 can be divided by 1. It can be divided by 49. It can also be divided by 7. That's the only other number that divides 49. Does 7 divide 30? No, it doesn't. So one of the ways that you could work this out is just do it in your own head. Think of the numbers that divide 49 and realize that none of those numbers divide 30. That's strategy number 1. So you would realize this cannot be reduced. It's already reduced. 49 over 30 is reduced. However, here's your other strategy. Go to the table, type 49 over x and 30 over x, and then look for any number that produces solid numbers, whole numbers. Okay, and what you're going to see is, notice, the only whole number in the blue column occurs at 7. Because like I said, that's the only number that divides 49. But it does not divide 30 evenly. It produces a decimal. And every other number in the blue column is a decimal. You're not going to find a pair of whole numbers anywhere. In fact, the only pair of whole numbers you're going to find on this entire table is all the way back at 1. That right there, 49 and 30, that's the only pair of whole numbers you're going to find. So that's the second method. So first method is just kind of work it out in your head. Think of what numbers divide 49. Realize that none of them divide 30. Second method is what I just showed you. Fourth method, which arguably is definitely the fastest, but I'm going to warn you, the fastest method requires the least amount of thought on your part. Okay, and that's dangerous because that kind of creates a situation where you're not even using your own brain. Okay, but if you type 49 over 30 and you hit the math fraction option, the calculator can reduce fractions for you. And you'll notice it doesn't do a thing to it. It just keeps it 49 over 30. Whereas the first problem was 75 over 90, we reduced that to 5 over 6. And if we had typed this, the calculator would have told us 5 over 6 is correct. Okay? All right, last one. Again, you cannot subtract across unless the denominators match. So I'm going to multiply the first fraction by the other denominator. I'm going to multiply the second fraction by the first denominator. This turns this problem into 8 over 12 minus 9 over 12. And there's nothing that says you can't get a negative fraction. That just results in negative 1 over 12. And I know right away that's simplified because there's no number that divides 1 other than 1. Thank you. Questions? All right, so we're going to change to analyzing. Notice the goal for today says use inverse variation to model word problems. This idea of inverse variation, I'll kind of connect back to that in a moment after we read through this problem a little bit and get a little far with it. Okay? So problem number 2 says, Yashka is celebrating her quinceañera. Her friend Hannah knows the perfect gift to buy Yashka, but it costs $360. Hannah cannot afford to buy the gift on her own, so she considers asking some friends to join in and share the cost. Part A says fill in each blank below to determine the cost per person based on the number of people. So now I ask you all, if 2 people split the cost, each person will have to pay how much? Remember I said at the beginning of the period, if you all are willing to participate and contribute answers, we're going to get through this faster. 180, exactly. If you take 360 and you cut it by 2, you divide by 2, you're going to get each person has to pay 180. How about if 3 people split the cost? 120. Again, if you just do 360 divided by 3. How about if 5 people split the cost? 72. Notice there's a pattern here. We keep doing 360 divided by, 360 divided by, 360 divided by. How about if 100 people, this one's kind of silly, $3.60. You got it. So if Hannah tracked down 99 other friends who are all willing to contribute to this gift for Yashika, each friend just give Hannah $3.60, and then she would chip in $3.60, and suddenly they'd have $360. Sounds like a lot of work, though, to track down 100 people, basically. Now, what do you notice about your answers for part A? As the number of people increases, as we go up from 2 to 3 to 5 to 100, what's happening to the cost per person? It's decreasing. This is why it's referred to as inverse variation. Okay? As one variable is going up, the other variable is going down. As there are more and more and more people, you have less and less cost per person. Okay, that is what's defined as sort of this idea of inverse variation. In statistics, we call it a negative association, two variables that move in opposite directions. All right, determine a function that can be used to model the amount each person would spend for the gift, depending on the number of people contributing to the gift. So if you have 2 people, or 3 people, or 8 people, or 14 people, or 27 people, to figure out how much each person contributes, what do? We've already done it 4 times, folks. I just need somebody else to tell me. If you have a certain number of people, let's just call it X, because it could be 4 people, or 17 people, or 27 people. How do you use that number to calculate how much each person is contributing? Divide what? 360. So that's the formula I'm looking for. Okay, if you want to figure out the cost, you just take 360 and you divide it by however many people there are. Now we're going to use that concept to complete part D. Part D says complete the table of values which would represent the cost each person would pay for various numbers of people contributing to the gift. Then sketch the graph to represent this situation. Now the table is mostly filled in for you, but, and this is going to help with the next problem, I just want to point out how quickly we could have filled in this equation or this table ourselves. All we'd have to do is go to the calculator, type in 360 divided by X. That's the equation we agreed on. And then go to the table. And the table literally tells you if there's one person, they're going to pay $360. If there's 2 people, they're going to pay $180. 3 people, $120. 4 people, $90. 5 people, $72. 6 people, $60. And notice those values are given to you. 1, 2, 3, 4, 5, 6. 360, 180, 120, 90, 72, and 60. Notice the table skips from 6 to 7. Or excuse me, it skips over 7. It skips from 6 to 8. I did that on purpose because in the table, 7 people sharing the cost means each person has to give $51.42.9. I wanted to avoid the decimal. Okay. So the table stops at, hey, come back, 12. We need to find 15, 18, and 20. So if we go down, if there are 15 people, they each pay $24. If there are 18 people, they each pay 20. And if there are 20 people, they each pay 18. So we got to record those numbers, 24, 20, and 18. So that's the first part of part D. It says complete the table of values. Now we're going to use it to sketch the graph. Now there are certain points that you should have that should be graphed perfectly. For example, if there's one person, that one person is going to pay $360. If there are 2 people, those 2 people will each pay $180. Even the third point should be in an exact location. 3 people each pay $120. The first point that's kind of in a, just put it in a reasonable spot, doesn't have to be perfect, is 4,90. Because there is no $90 line. There's a line for 80 and there's a line for 100. And so it's your job to just try to put a point that's somewhere perfectly between 80 and 100. So 4 people, and I'm going to put a point kind of right in between 80, and 100. That represents if there are 4 people, they're each paying 90. Okay, I'm going to zoom in on this a bit more for the remaining points, just so people can see these a little more clearly. Okay, so I've already gotten the 90. Now, if it's 5 people, and this is one where you just really have to just do the best you can. 72 is kind of an awkward location to try to graph. But 5 people would be $72. It's kind of like not perfectly between 60 and 80, but it's really close. Now, 6 people is $60. That should be an exact location. Okay. 8 people is 45, so that's like not, it's like a little bit above 40. 10 people is 36, so that's a little bit under 40. 12 people is 30, so that's perfectly between 20 and 40. Now I got to scan over for 15 at 24 and so on. So 15 is $24. That's like a little bit above 20. 18 is 20 people. Now that's a point. This point right here, that's a point that should be perfect. 18 people, $20. That's an exact location. But $20 and 20 people and $18, that's kind of just under that line of 20. So for some of the points, yes, they should be in an exact location, but for a number of the points, it's okay if it's just reasonably close. Okay. Now I'm going to drop this down. I'm going to draw a curve that goes through all of these points as best I can. And I'm going to put an arrowhead on the right. I'm not going to put an arrowhead here. To me, it would be wrong to put an arrow there. What I would actually argue, because this is a real world problem, is this function starts at the point 1, 360. Okay, it's not a location where it just keeps going. Okay, it starts at the point 1, 360 because you have to have at least one person that's contributing to the gift. And if you only have one person, they're going to have to pay all 360. Okay, there's no reason to go higher than 360. That is the cost of the gift. And you can't have less than one person contributing to the gift. Like somebody's got to get it. Now, on the right side, I would argue this thing could keep going. I mean, as we saw in the beginning, it doesn't need to stop at 24 people. We could get 100 people. You know, if you followed this curve way out to the right, keep going right until you hit 100 people, it's getting closer and closer and closer to $0 because if you get 100 people, each person only has to pay $3.60. Okay, Landon, you good? Now, there is, you know, the reason I'm making a big fuss about this graph, it starts at this point, but over here it keeps going. The reason I'm making a big deal about that is because we're about to answer questions about the domain and range. Okay? What I would argue is that for the domain, which again represents like how far to the left, how far to the right, well, you can have at minimum one person contributing to the gift, but there's no limit to how many people you can ask to help get the gift. So this thing starts at 1, but then it just shoots off to the right forever. Okay. For the range, now that deals with cost per person. Okay. Well, the most any one person is going to have to pay is $360 if there's only one person. But as you get more and more and more and more people, they're going to have to pay less and less and less and less. The cost never actually gets to 0 because everybody has to pay something, no matter how many people you get. But I would argue that the range is it's getting closer and closer and closer to 0, but the highest it ever reaches is 360. Okay. Thank you. Thank you, Mr. Fee. It would include 360, hence the bracket. Okay. All right, so domain is talking about number of people that could be involved. You need at least one. You can have as many people as you want. The range is talking about how much each person has to pay. Okay, and notice I put a parenthesis around the 0 because I'm not including 0. Everybody's going to have to pay something. But the more and more and more people you get, the less and less and less and less they have to pay. It gets closer and closer and closer to 0. And the most anyone would ever have to pay is 360, and that's only if you have one person. Okay. Now, by the way, just going out of order a little bit, I just referred to the maximum. There is no minimum. The function keeps getting closer and closer and closer to 0. but the maximum occurs if you have one person that pays $360. That is the maximum. Now, the function itself is always decreasing. It is never increasing. So I'm just going to copy my domain. Okay, because as you get more and more and more people, the cost just keeps going down and down and down and down. That's why this is referred to as an inverse variation. Okay. Now, here's where we're going to get into, I'm going to accept a couple different answers. Right end behavior and left end behavior. Traditionally, when you talk about left end behavior, right end behavior, what you're really talking about is what happens as the function keeps going and going and going and going. So on the right side, it does keep going and going and going and going, and it's just getting closer and closer to 0. Okay, there's no arguing that. As it goes further and further and further to the right, it just keeps going down, 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 because the more people you get, the less they each have to contribute. However, on the left end, here's where it's a little bit weird. The function stops at the point 1, 360. The function does not keep going to the left. So I think that there's a real argument for there is no left end behavior, because the whole idea of end behavior is what does the function do as it keeps going and going and going and going to the left. Now, that being said, if somebody wrote the point 1, 360, I'm going to give you full credit for that, because at least you're communicating that you notice the function stops at 1, 360. So I would take either one of those answers. If you wanted to say D and E, well, that to me means you're recognizing the function doesn't keep going. It stops. I have no problem with that. You're right. It doesn't keep going. But if you want to give me that point, that also kind of communicates you understand the function stops. Now, by nature of the function itself, it never touches either x-axis. Okay, you're always going to need, you can't have nobody getting the gift. And you can't have anybody contributing nothing. Everybody has to pay something in order to pay for this gift. Okay? We're going to do one more context problem similar to this, where we want to build a graph and then, excuse me, build a graph and then answer the properties. Questions? Okay. So very similar concept, still inverse variation. As one variable goes up, the other variable goes down. Okay. So now we're at the top, page 32. It says you invited some friends over, so your mom baked 48 cookies for you and your friends to share. You are not sure how many of them are going to show up, but you want to split the cookies evenly. How will the number of cookies each person eats change if more of your friends show up? Folks, what happens as more friends show up? How many cookies do you eat per? It decreases, exactly. As more and more people show up, each friend is going to get less and less cookies. Okay, this is again why it's called inverse variation. As one variable goes up, the other variable goes down. Now, part B says write an equation that represents the number of cookies each person will eat if X people show up and eat cookies. Okay? So, how do we figure out how many cookies each person gets? What do we do? If 2 people show up, or 3 people, or 4 people, or what? And what are we dividing? 48. You got it. So it says the mom made 48 cookies. If you want to know how much each person, well, then you just do 48 divided by X. Okay? Now, this says complete the table below that relates the number of people X to the number of cookies f of X. Be sure to select factors of 48 for X people so the cookies can be divided evenly without cutting them. Okay, I'm going to type that equation, 48 divided by X, into the calculator. And because the directions say you cannot cut up cookies, you have to avoid that situation, I'm going to ignore decimals. So I'm going to go to y equals, type 48 divided by X. I'm going to go to my table. Let me jump back up to the top here. So if it's only you, if it's just one person, that one person is going to get 48 cookies. That's what they already gave us in the table. And they also gave us the other extreme point. If 48 people are there, each person gets 1 cookie. Okay. However, if 2 people show up, they each get 24. 3 people show up, they each get 16. 4 people are there, we get 12 per person. I'm going to skip 5 because that gives me a decimal. And the directions specifically say, let's pretend you don't have the ability to cut up the cookie. Like everybody should be getting a whole cookie or not at all. So I'm not gonna record 5. I'll get 6. I'm not gonna record 7. I'll get 8. And if I scan down, it takes a while to get to, oh, looks like 12 is an option. 16 is an option. And 24 is an option. So those are the numbers that I'm going to copy into my table. I targeted the values. Remember, I said 1, 2, 3, 4. I'm going to skip 5, take 6. I'm going to skip 7, take 8. These are the numbers that produced whole values. So filling in that table is part C. Part D is use the table to graph f of x. Now I want to point out that the scale on this graph ends at 24. So we will not have the ability to graph this point or this point. But I want you all to remember that those points do exist. That, you know, if we had a complete graph, we'd be able to graph a point way up here somewhere at 1, 48. There's a point like way up off the grid. Also a point way over here at 48, 1. Okay, that'll be important when we're answering the features down below. Yes, sir. If you put an arrow and you like wrote the coordinate pair 48, 1, I'm not going to say that I'm going to require that, but I am going to include the arrows when I graph it. So I'll include that when I graph it, but I'm going to put the coordinate pairs in green. Now, every single one of these points should be graphed perfectly because every single one of these points can be placed exactly at the right location. 2, 24, 3, 16, 4, 12, 6, 8, 8, 6. Every single one of these points should be placed exactly in the right location. Okay. 12, 4, 16, 3, 24, 2. And this is where Sam's question, I think, is where I'm going to address it. You should put an arrow here and, oh, let me draw that curve a little bit better. There we go. That looks a little bit better. And I'm going to put an arrow here. If you wanted to write, as a reminder, the graph stops at the point 48, 1, and up here it stops at the point 1, 48. I'm not going to require you to write that, but having that image in your head is a really important part to answering the features correctly. So I want to remind you all, before we get to the characteristics of the graph in a moment, please remember this function does not keep going forever. In fact, you could argue that the end behavior on both sides does not exist because the function does not keep going. It stops. Now, on the right side, it stops when there are 48 people that each only get 1 cookie. On the left side, it goes up and up and up and up and up and stops when there's only 1 person that gets 48 cookies. Those 2 points, by the way, are your max and min. Your max and min, your max occurs when 1 person gets all 48 cookies. That's your maximum. Your minimum occurs when there's 48 people and each person only gets 1 cookie. That's your minimum. Now, in terms of domain and range, remember, domain is your x values, bless you, which represents the number of people. What is the minimum number of people that can be involved when each of these cookies? 1. And what is the maximum number of people that can be involved? Remembering that the rule was you can't cut up the cookies. 48. That's your domain. The minimum number of people you could have is 1. The maximum number of people you could have is 48. Now, believe it or not, the range is exactly the same, but for a very different reason. The range is the up and down, the number of cookies per person. The minimum number of cookies any one person can get is 1, and that's if there are 48 people. The maximum number of cookies each person can get is 48, and that's if there's only 1 person. So notice the domain and range are the exact same thing, but for 2 very different reasons. The domain says you could have anywhere from 1 to 48 people sharing these cookies. The range says each person might get as little as 1 or as many as 48, again, depending on the number of people. And once again, you have a function that will never touch any of the axes. You cannot have an x-intercept because you can't have a situation where people get absolutely nothing. Like somebody's going to eat the cookies. And same thing with the y-intercept. You can't have a situation where nobody's doing anything with these cookies. So you have a graph that won't touch either axis. Oh, and I should have mentioned, just like the last graph, this graph is only decreasing. So I'm just going to copy my domain. And now we're done. All right. So we are done for the day. Sorry, I didn't quite get you 10 minutes. That's always kind of an unofficial goal of mine. Sometimes I hit it, sometimes I don't. But based on today's lesson, you should be able to complete homework 88 at this point. All right. Thanks for watching. Have a good one.